Morning. Here, actually, let's start here. We may as well gather stuff up. So, guys, as you're getting settled and listening to the rain lightly falling on our roof, if you would gather up the following 4 items, because item number 3 you don't have yet, but we're going to fix that right now. So, guys, you need to grab note-taking materials. One of those items should really be a pencil and not a pen, simply because we're going to be working on some lab stuff today. Then, guys, in addition to that, you will need a calculator. Then you're going to need the periodic table that I'm providing you. And then in addition to that, you're going to need the lab write-up that we started last time. Can I just hand those to you? Thank you. How we doing, boys? Good. Gage, good morning. How are you? Good. What's that? Let me get you a pencil. I think you're going to be happier with a pencil. It broke. All right, where's my collection of pencils? Oh man, someone cleaned me out. Do you need one? There you go. All right, there you go. You're welcome. Hey, I'm hoping that some of you do this just as a part of your daily routine. But guys, I understand that some of you don't, and some of you yet haven't found this beneficial and necessary. But what I'd like to do is I'd like to take a couple minutes and I'd like to calendar with you. Calendar now is not just a noun, it's also a verb. It's something that you do to keep your life in order. And so guys, taking a couple minutes, let's spend a second here and let's look over the calendar so that you guys have a sense of where we are and where we're going. And then we'll turn our attention to the 2 tasks that we need to complete today. So guys, joining me at the calendar, today is the 10th, and we're going to do 2 things. We are going to wrap up the lab that we started last time. And then, guys, we are going to move into the last of the new material for this unit. And guys, when you hear that idea of the last of the new material for the unit, you then realize the unit's coming to a close, and units always end in tests. So let's keep going. So then on Thursday the 12th, guys, you're going to be right back in lab. So on Thursday, we will turn in the lab that we're in process on. And then, guys, we're going to grade homework, and then we'll get you right back into lab on Thursday. Then coming back on Monday, we are going to then regroup around the lab that you did on Thursday. And then, guys, we're going to spend some really important time on Monday, and I'm going to teach you to study for tests. We'll talk more about this later, because I would propose to you that sometime in junior high, all of a sudden your junior high school teachers turn to you, and in order to either guilt or motivate you, they said, hey students, there's a test next time, make sure you study. And they never taught you how to do that. And guys, you go home, and there are many different ways to study, as there are people in this room. And I would propose to you that most of you are doing it wrong. So guys, what we're going to do on Monday is we're going to spend some time, and we're going to talk purposefully about how to study for math and science tests. You're going to find it valuable. Then guys, on Wednesday the 18th, you're going to have your first unit test. So again, as an overview, here's how it goes. Wrap up a lab, last a new material today. Thursday will be the next lab of the class. Monday will be wrap up that lab and talk about how to study. And next Wednesday will be your test. So guys, thoughts or questions about any of this? Other than you're sitting there going, oh my gosh, I wish all my teachers were this organized? Okay, maybe not. You guys all good? Okay. So guys, with that said, and guys, what you need to do is title that sheet as such. The title at the top, the date today is the 10th. And guys, today what we're going to do is we're going to talk briefly about some things that you need to know about metric measurements. And then we're going to talk about density. But guys, before we do, we're going to step out of the new material and we're going to talk for a minute about your labs. So guys, again, titling your notes, metrics and density. And the date today is the 10th. Some of you right now are sitting there staring at me with blank faces because you have no clue what we're doing. Guys, it can't be any more clear than this. Grab a sheet of paper, write metrics and density at the top. The date today is the 10th. Guys, it's time to engage. Here we go. You guys all settled? Okay. So, guys, here's the problem. Well, actually, I don't want to go there yet because you guys are all going to pay attention to this. So, guys, let me go back first. Guys, here's the hazard of what we're going to do today. We're going to spend the next 20 minutes and we are going to talk about perfecting your labs. Now, guys, I'll be honest with you, I'm a little disappointed because as I walk around the room and look at your labs, you knew they were due today. I should be collecting these from you right now. And guys, if I did that, a lot of you would be in a world of hurt. Shame on you. You knew that you were to walk in today with these labs done. Now guys, here's the problem. Spencer, are you okay? Guys, here's the problem. Me right now saying, hey guys, we're going to gather together and look over these labs is giving you a free pass. You're going, oh, Knappenberger didn't mean it. He didn't really mean for these labs to be done. Maybe that's always going to be the case and I can just float through these things and he's always going to cut us slack. Now guys, this gets even worse because what are we doing next Monday from the calendar? We're going to go over the lab that you did Thursday. Guys, here's the method to our madness. For this first unit, we are training you how to write up labs. So the idea, which many of you are missing out on, the idea is that you go home, write up the lab. We then look at what these are supposed to look like. You have the opportunity to edit and correct and perfect your labs so that then when you turn them in, they're perfect. But guys, understand, we are not going to do this anymore after this unit. Starting in the next unit, we will not post-lab labs, and they will be due, and some of you, if that were the case right now, would be in a world of trouble. So guys, understand, we are not developing a pattern, and we're not signing off on your lack of responsibility. So, for those of you that wrote up the lab, you're going to have a rich experience right now as we talk about what these are supposed to look like. For those of you that didn't do the work, guys, you're going to find that some of this is going to be completely lost on you because you don't even know what you're doing because you didn't spend the time to do it. So, with that said, guys, grab your labs and let's get these things perfected. So, guys, in total, this is what your labs should look like. And guys, what I'd like to do is I'd like to go through this section by section, line by line, word by word, and I would like to answer your questions, and I'd like to point out the things that I will be looking for when I grade your labs and make sure everything of your lab. You may remember, and I mentioned this in class, guys, two important things here besides the numbers. One of those was to put units on your numbers. So guys, go through all 5 of your measurements, and if those units are not on your numbers, put them there. Guys, measurements 1, 2, 4, and 5 are all masses, which then receive the units grams. Then guys, finally, measurement number 3 is the only volume measurement, and that receives the units milliliters. Now guys, if you are right now writing down these units, here's what I'd like you to do. Circle the units that you are writing down. That is a physical reminder to you that you didn't do it right the first time, but you now understand that those units should have been there. Thunder for effect. And guys, this is now that reminder to you that says, okay, now I get it. I need to put units on my numbers. I didn't before, but I will give you credit as if you had. You guys okay? Questions on units? Okay. Then guys, the next thing you need to do is this. You will notice that these 4 measurements all go to 2 decimal places because these were taken on a digital readout, and we always write down, just like you learned before, we always write down all of the units. Now guys, look here. This is a volume measurement that you made by comparing against a scale. You had a graduated cylinder. And guys, the units on this graduated cylinder are whole milliliters, so you should estimate to what? To the 10th place. Many of you did not. And guys, understand that it's actually academically dishonest to go back then and fudge your data. But I'm going to allow you to do this. Guys, if you did not measure to the 10th place, whatever number you have written down, put dot and question mark and circle it again as a physical reminder to you that you didn't estimate to the tenths, which you should have done, but now you understand, and I will give you credit for it as if you did. So guys, that's what I wanted to talk with you about in the data chart. Anything there you need to discuss? You guys all okay? Okay. So then guys, moving down into your calculations. Guys, please understand, this is not me trying to get you to do stuff the way I do stuff. This is us together figuring out how to represent these calculations in a manner that is accepted by the scientific community. So guys, we've got 2 different kinds of calculations. We've got 2 mass by difference calculations, and then at the bottom, we have a percent error calculation. So guys, let's talk about these 2 first. So guys, anytime we do mass by difference, first of all, these have to be in columns. Looking at your papers, some of you did this as a sentence. Mass of beaker plus salt minus mass of beaker gives you the mass of the salt. That's not okay. Guys, these have got to be in columns. This column where you describe the subtraction has got to be first. So if you did the math first and then wrote the explanation as an afterthought, you need to redo it. So guys, we always start with the explanation and then the math. The columns line up, conserving decimal places. Similarly there, the explanation first. This time it's the dish, the watch glass, and the salt, minus the dish and the watch glass. And again, the columns line up and they're neatly organized. Yes, sir? Yeah. Then you got number 1 right and number 2 is wrong. So add it. So guys, understand right now what we're doing is we are editing your labs so that you now will have, and this would be a good time to hand these out. Guys, here's blank copies of the lab. Because when you turn these in, scribbles and horrible erasure marks and all the things that your labs are turning into now as you are trying to either complete or change or edit your labs. Guys, these are high quality products. Is that your lab? Oh, okay. Oh, gosh, that looks good. I was afraid it was the other one. It's like, no. All right. So guys, here's a blank copy of the lab. If you would like to use this in order to create a pristine version of this lab, please do. If you choose not to use it, you can just return it to me at the end of the day. I'll reuse it. But guys, this is what your mass by difference calculations need to look like. Any questions there? Please. Watch glass. Yeah, remember that little dippy guy that we used as a lid? Yeah, I just abbreviated it WG for watch glass. You guys okay there? Okay, now guys, watch the bottom. This is important. Can we talk? You need a minute. Let me give you a second to sort of catch up with what we're doing, and then we'll proceed to the bottom and we'll talk about this percent error calculation. Guys, as you're working, I understand that the tone of the room is a little heavy right now. You're going, oh my gosh, Knappenberger's angry, Knappenberger's frustrated. Guys, understand none of that is true. I am a little disappointed by the number of you that didn't complete this. I think you understand now that you won't make that mistake again. But guys, understand, the thing that you're experiencing, perhaps for some of you, is this expectation that when we do lab work, it is very, very well done. And I know this is the first lab you've ever written up, and maybe I'm not communicating that in a way that's inviting. But guys, understand, the expectations for lab are through the roof. This is your very best work. These are the only things that you ever turn into me. You never turn in labs, and tests you obviously turn in. But in terms of like original work, these are the only things that you ever turn into me. And they're always your best work. So guys, did you have time to do your mass calculations? And you remember this is posted on our website, right? All the more reason you're without excuse, because I showed you that an example of this is on our website. And I'm guessing that none of you checked. Well, maybe a few of you. So now guys, let's look at this percent error calculation. Guys, looking down at the bottom, the way that this works is, number one, we always write out the equation. If you do not have the equation written out, it needs to be there. Then guys, in addition to that, let me zoom out for just a second. In addition to that, we need to figure out which of your data is your measured and which of your data is the accepted. And guys, the thinking goes like this. The accepted value is the amount of salt that you should have got. It's your goal. Guys, that would be your top number. And obviously you're using your own data. But guys, the accepted amount of salt is the amount that you started with. That's what you should have got back. Your measured amount is the amount that you actually did get back. So relative to my numbers, that would be 1.02 and 0.81. But guys, the important thing to think about here then as you do the math is remember that you do the subtraction first. So when you do the subtraction, guys, this first subtraction works out to negative 0.21 divided by 1.02. And remember, when you do the subtraction, you don't care about significant digits, you care about decimal places. So this would be 2 decimal places and 2 decimal places. So that gives you 2 decimal places there. And then when you do the division, you now care about significant digits. This would be 2, this would be 3. That means you get 2 in your answer. So my answer is 21%, dropping the negative because it's absolute value. So guys, questions now about any of the calculations? You guys okay? Remember, subtraction first, decimal places, division second, significant digits. So guys, I hope that you're beginning to appreciate the level of detail that we're looking for here. You can't just stumble through this and be successful. You need to write things out, you need to take your time, you need to be purposeful about the things that you're doing. So guys, make sure that you're thinking through this stuff. So guys, in general, and you guys understand, here's what should happen. Guys, when we get together on Thursday, the very first thing we're going to do is you guys are all going to get up and you're going to put this lab in the basket. And guys, this is my hope for you, that when you walk up here and put this lab in the basket, you should have this experience of going, this thing that I'm turning in is a representation of everything that I'm capable of. This is my very best work, and you should have the experience of, hey, this is good stuff, let me turn this in. Because that's your goal every time you turn in a lab. So, any questions on the front of the lab? What about on the back? Flip them over if you'd like. I don't even remember the conclusion questions. The first one is, okay, so why did we measure the beaker, the mass of the empty beaker and the mass of the empty dish first? And then the second one is all this stuff about estimating and making measurements. So guys, anything there that you need clarification on? You guys okay? You're clear on that? Okay. So guys, the question then becomes, what should these look like? So guys, understand, I know that this is a science class, but what you're going to find progressively throughout this year is we write in here a lot. And I'll be honest with you, I write well. and I'm going to invite you to write well as well. So guys, as you're jotting down, as you are writing out your answers to these questions, guys, understand you're writing in complete sentences, you're writing legibly, you are fully developing answers to these questions. And guys, in that spirit, you'll notice that question number 2 actually is 4 questions in one. So guys, you can't answer question number 2 in less than 4 sentences because there are 4 separate questions there. So guys, as you're thinking through the progression of thinking in this question, make sure that you're addressing each of those individual questions. So guys, with that said, back to you. Anything you need to talk about with this lab, anything I can do to support you so that you can knock this out of the park on Thursday. You guys really okay? You guys are good? You're sure? Do we need a minute to listen to the rain? You guys are okay? You're sure? Okay. So guys, let's do this then. Today, guys, is actually going to be a transitional day. At the end of the day today, you're going to have time to finalize these labs. Some of you may even choose to turn them in today, and that's just fine. In addition to that, you're going to have a slight homework assignment that will be a precursor to the lab that we're doing on Thursday. But guys, along the way, there are some terms that we need to finally define, and there's another calculation that we need to talk about. So guys, I need you to do this. Take those labs. You should have 2 copies of it now. Take those and physically put them in the lab section of your notebook and close your notebook, your binder. Because guys, I know if you don't, you're going to be distracted by it. And so guys, we need to have that experience. Just get rid of it. But again, we're going to be done in about 20 minutes. So you're going to have more than half an hour today to either complete your homework or complete your lab, or perhaps both. So guys, what you need then are the remainder of the items that you should have in your possession, which are your calculators, note-taking material that is already labeled, and then guys, finally, those periodic tables that I gave you. So guys, let me let you get settled for a second, and then we'll dig in. You guys all set? Are we okay to dig in? Hey, so guys, what I'd like to do, just so that the transition is more seamless, what I'd like to do is I'd like to talk with you about these periodic tables first. So would you grab these with me really quick and let me orient you to them? So guys, these are the references that we are going to use for the entire year. This is fair game for the entire year. There will never, well, there will be one, but with the exception of one moment, there will never be a moment where you can't use this in class. That means you don't have to memorize any of this for this class. Guys, I don't believe that memorization is a valuable practice. You don't have to memorize the names. You don't have to memorize the abbreviations, although you're going to find quickly you've got a lot of this memorized just because you use it so much. But guys, you're not going to be asked to memorize this stuff. What I do want to do, however, is familiarize you with the information that's on here so that you know how to access it. So guys, the first thing you need to do is it's double-sided. If you flip it over, you'll see that there's information on the back as well. The thing that I want to show you is this. Guys, you'll notice that these periodic tables are very, very dense. There's a lot of information on these periodic tables. Mine's it's similar, but a little bit different because anyway. Guys, this is what I want to point out to you. Down here in the lower left-hand corner, turn to the front of the table. Guys, down here in the lower left-hand corner, you will notice that there is a key. Guys, none of the data that is in the chart has units on it. The reason is it would just become too cluttered. So down here in the bottom left-hand corner, you'll notice that there's a key that tells you what each of these numbers represents and also tells you the units for those numbers. And so guys, the information that we're going to be using today is the information in the bottom left-hand corner. I wonder if yours is, can I take a peek? Guys, it's in the bottom left-hand corner. Are yours in blue? Yours are, oh, they didn't colorize this anymore. Well, they did a little bit, not as much. So the location is the same. So guys, the information that we're going to be accessing today is the information in the bottom left-hand corner of each one of these cells, because guys, today we're going to be talking about density. So do y'all see where that is in the cell? Okay, now you can then find that information in each one of the boxes for each of the elements, right? Okay, so guys, with that said, that provides the overview of what we're doing today. Guys, today we're going to be talking about a concept called density. We're going to talk about it conceptually, we're going to talk about it mathematically, we're going to do some calculations, and then guys, in lab on Thursday, you're going to get your hands dirty, and you are going to be doing a lab where you're going to be measuring the densities of objects. Now guys, I'm just going to tell you right now, you're also going to do a lab in Wednesday during the test. Literally in lab on Wednesday, you're going to get up in the middle of the test, and one by one, without your lab partner, you're going to be repeating the lab that you do tomorrow, Thursday, on Wednesday during the test. So all of this is leading in that direction. All right, so guys, with that said, here's what you need to do. In your notes, as wide as your piece of paper, and then guys, make this 1 row tall, make this one 4, and make this one 4, and make this as wide as your paper. Guys, you need to recreate this table in your notes. So guys, as you're recreating this table, let me put this in context for you. So last time, well, today, we looked at the salt and sand lab. And guys, looking over the data, you'll notice that we actually took 4 mass measurements and we took 1 volume measurement. But guys, the thing is we in this class have never talked about what is mass and what is volume. So today what we're going to do to start is we're going to define those terms. Then we're going to bring mass and volume together, and we're going to talk about density, and then we're going to do a couple of calculations, and then you're going to have time to work on your homework and work on getting your labs written up. Lily, this week the concurrent thing doesn't interrupt? Yeah, that's nice. That's cool. What class are you taking concurrent? Is it over the TV? Okay. How do you like learning from TV? Is it okay? Right. It's a little creepy. Yeah, it's like a stalker. But it works okay. Yeah. Yeah. You're the only one in the class? Oh, gosh. That's awesome. All right, you guys all caught up? You're good? Okay. Are you sure? Sorry, I was interrupting Lily, so she's probably behind. You guys okay? Another second. Adam, what's his name? It's Wolf is his last name. Okay. Do you know? You don't know him then. Okay. How about now? You guys all right? Okay. So, guys, this is just a way that I can help you organize information about ideas. I'm big into tables because they help us organize thoughts. So guys, what we're going to do is we're really going to go backwards and talk about things that we've been doing for the last 3 weeks and never really defined. So guys, what we need to do is we need to talk about volume and we need to talk about mass and weight. Now guys, if you've taken physics, you know that mass and weight are not the same thing. We're going to use them interchangeably. We could say weigh something, we could say find its mass, and in this class we're talking about the same things. If you understand the distinction from physics, that's great, but we're not going to worry about it. All right, so guys, with that said, and I think you didn't ask, so we've been doing volume measurements and mass measurements for a while, and because you didn't ask, I assume that you're probably okay with this, but guys, let's talk about it. When you went into lab the other day, and when you measured the volume of some water, guys, what were you measuring about that water that you then used to dissolve the salt? What does it tell us when we measure the volume? Beautiful. How big it is. How much space something takes up. So guys, when we're measuring volume, we're talking about how big something is. The bigger it is, the greater its volume. Now guys, this is where things get a little wacky. You know that when you went into class to make these volume measurements, we use the units milliliters. But guys, what are volume units in the English system? We're never going to use the English system, but it's a good reference. What are our volume units in the English system? Fluid ounces. What else? Cups. Nope, that's metric. Cups, quarts, gallons, pints, teaspoons, tablespoons, hogsheads, barrels, bushels. Holy stinking what's going on, right? Guys, the English system is a train wreck. You don't even need to, well, maybe if you want reference. Guys, we've got cups, we've got quarts, we've got gallons, we've got all these absolutely ridiculous units of volume. And guys, we are going to use none of them. We can do way better than that. Never mind. We can do way better than that. So guys, let me introduce you to the metric units of volume. Ready? This is pretty smart. This guy right here, any thoughts? Milliliter. So when you measured the volume of your water is 20 milliliters, it means it was about 20 of these. So guys, if this is a milliliter, this is a liter. And 1,000 milliliters fit in a liter. Now guys, the thing that's really intelligent about that is this. I don't know if you're aware of this or not, so let me show you. Guys, by definition, how big is a milliliter? And guys, look at the answer. It's a cubic centimeter. A milliliter, by definition, is a cube that is a centimeter by a centimeter by a centimeter. We call it a cubic centimeter. And then, guys, a liter, by definition, is a box that is 10 centimeters by 10 by 10. 10 by 10 by 10 is 1,000. But guys, that actually has a different number, a different name. It's a tenth of a meter, which we call a decimeter. So guys, with all of that said, these are our units for volume. We use milliliters, which are the same as centimeters cubed. And then guys, we will also use liters, which are the same as decimeters cubed. So guys, how then do we measure volumes in the metric system? Well, this gives us an interesting freedom, because guys, we can use graduated cylinders, but we can also use rulers. Guys, you can actually measure the volumes of things in the metric system by using rulers. You can't do that in the English system. A gallon is not a foot by a foot by a foot. There's no connection. Well, there is, but it's not that simple. So guys, we'll use graduated cylinders to measure volume. All right, so now let's talk about mass or weight. So guys, for our units, for our purposes, mass and weight is an amount of matter. How much stuff? How heavy is it? So guys, when we think about this in the English system, what are our units of mass and weight? Ounces, pounds, tons, those sorts of things. Guys, we're not going to use those. Instead of that, guys, we are going to use the gram. And then another one I'll share with you in a minute. But guys, do you remember well enough that measurement activity? You weighed two different things in that measurement activity that both had the mass of almost exactly a gram. Do you remember what either of them was? Good. Guys, when you think about a gram, think big paper clip. That's how much a gram is. But guys, that is not actually the definition of a gram. Do any of you know what it is? What else weighed a gram, Susanna? Did you guys know that? This is brilliant. Guys, the definition of a gram is exactly the mass of 1 milliliter. Station 15, you took the milliliter of water and you put it in the dish. And guys, that should have weighed almost exactly a gram. It wasn't perfect because the dropper's not perfect. But guys, by definition, a gram is the mass of a milliliter of water. So a gram is either a milliliter of water or a big paper clip. But guys, obviously this isn't that much stuff. If you wanted to find your mass in grams, it's going to be tens of thousands of grams because this isn't that much stuff. So guys, many times we will use a kilogram instead, which is a much larger amount of stuff. If you're curious, guys, this is 2.2 pounds. So a kilogram is about 2 pounds. So guys, how then do we measure these things? Well, the answer is we use balances, scales. So there you have it. Guys, now you have a working functional definition of both mass and volume. Guys, what we're going to do to round out the day today is we're going to bring those ideas together, the relationship between mass and volume, and we're going to talk about density. Then we're going to do a couple calculations, and then guys, you're going to have time to get your homework done. So, guys, moving into the next topic, the last topic for the unit, goes like this. Guys, this is how we're going to round out the day. Just put a topic in your notes, density. All right. Perfect. And good. Okay, so guys, let me give this to you in definition form, and then we'll talk about it more deeply. So guys, by definition, density is a measure of the compactness of matter. But guys, when we think about that, we think about it mathematically as being a ratio. It is a ratio of mass to volume. Because I know that you know this, when we talk about ratios, we're talking about division. So mathematically, density looks like this. It's mass divided by volume. So guys, now let's put some units to this. Looking up in your notes, what are our units for mass? Grams or kilograms. We're going to use grams. Guys, what are our units for volume? Milliliters or centimeters cubed. So guys, bringing those two measurements together, our units for density are going to be grams per milliliter or grams per centimeter cubed. And guys, hopefully you understand that these are equal. A milliliter is a centimeter cubed. And so these are equivalent measurements. So guys, once you've got that scratched into your notes, guys, go down and look at the key on your periodic table. Guys, grab your periodic tables and look in the lower left-hand corner at the notes down there. What are the units for density on our periodic tables? Can you squint that small? Aha! See, guys, all of the densities on the periodic table, if you look down here in the lower left-hand corner, they are all given in grams per centimeter cubed. So those are the units on the periodic table. They are also the units that we're going to use. You get the idea? You okay? I'm a horrible golfer, but all right. So, guys, here's then what you've got to be able to do. In lab on Thursday, you are actually going to go into lab and you are going to be figuring out the densities of substances. Some of them will be liquids, some of them will be solids, but guys, in lab, you're going to be figuring out densities. The problem is this: we don't have a density meter. You can't directly measure density, so what you are going to do is measure the mass of the substance. You're going to measure the volume of the substance, and then from that you're going to calculate density. So guys, to do that, we're going to look at a couple sample calculations. We're going to work through these together, and then guys, we're going to turn you loose on homework. So I don't know that you need to necessarily write down the examples, but we are going to solve these together. So guys, this is the kind of stuff that you're going to be doing in lab. Be ready to solve this with me. So guys, it says we've got a metal block. So we've got a metal block kind of like this. And we find the mass of the block, and it weighs 100 grams. We find the volume of the block, and the block has a volume of 8.81 centimeters cubed. Now, you guys, you'll notice this is an interesting question. It says, if the block is a metal, what is it? I love that the thunder is right on cue. So, guys, how can we figure this out? How can we identify what that block is based solely upon its mass and volume? Go ahead, Jose. Bingo. So you said a lot of stuff in a really small sentence. So you said putting the numbers in what? Okay, so into the equation. And what does that allow us to calculate? The density. And once we know the density, then what do we do with that number? Wild goose chase, find it on the periodic table where they match up. That's our element. So guys, let's work on that and see how we do, because this is some of what you're going to be doing in lab on Thursday. So guys, working with me, get used to this. No apologies. You will always write down an equation first. Guys, solve this with me. So density is mass divided by volume. Guys, again, in this class, you will never memorize equations. They will always be given to you. But you certainly will be using them, so you write them down. So now, guys, allowing the equation to guide the process, the first thing that we need to know is the mass. Is that the 100 or the 8.81? The 100. So the mass of this thing is 100 grams. Now, guys, need to know the volume. That is the 8.81 centimeters cubed. So now, guys, grabbing your calculator, run the numbers and round to the proper number of significant digits. Guys, you do it first, and then we'll talk about what the answer should be. So guys, when I do the division, I get 11.35073,780. But obviously that's not the answer, because that's way more accurate than our measurements. So now we need to round. So guys, how many significant digits do we get in our answer? Let's do this again, guys. If you don't know this, now is the time. Guys, how many significant digits do we get in our answer? The answer is the fewest. So guys, how many significant digits are in 100.0? I love it. There's 4. So guys, this is significant. This is significant. Those are trapped. So that would be 4. Then guys, in the denominator, we've got 3 significant digits. So if we've got 4 on top and 3 on the bottom, we get the fewest. And that would then limit us to 3 significant digits. But guys, notice, in addition to the 3 significant digits, the way the problem is set up, it also gives us the units for our answer. So guys, allow me, and I don't know if we're just distracted by the rain or if it's just early and you guys are low blood sugar or what's going on. But guys, if you do not understand this idea of how to manage significant digits, you have got to get help. Guys, now is a wonderful time to do that. I'm relatively free during Pride. I'd love to bring you in. I'll also sit with you right now. We're done in 3 minutes, and I'll sit with you now. But guys, if you can't navigate significant digits in calculations, you are not okay, and you need to address that. Okay? So guys, questions about this part? Then let's finish Jose's thought. So guys, you'll notice the question doesn't say, what's the density? The question says, what is the element? And guys, let me just sort of put you out of your misery because this could take forever. So guys, look in this region of the periodic table to figure out what element this is. Do you see it? It's not a perfect match, but it's very, very close. Do you see it down element 82? Guys, the closest match that we're going to find is lead. Lead has a density of 11.34, which is as close as we're going to get to 11.4. And so guys, we can say with some certainty that this is lead. Now here's an interesting thought. Guys, does lead float or sink in water? Sinks, obviously. Guys, we're fishing and we use lead to take power bait or whatever to the bottom of the lake. This is why. Lead is 11.5 times more dense than water, and consequently it sinks. Because guys, the density of water is 1 gram per centimeter cubed by definition. So if water is 1, anything more dense than water sinks, and anything less dense than water floats. So this is 11.5 times more dense than water. What's the most dense thing on the periodic table? Gold is more dense, right? Holy smokes, gold is 19. Platinum next to it is 21. That's element 78. Oh man, it goes up from there. So iridium is 22.5-ish. Is that the most? No, yeah. Is there anything more dense than iridium? Where's that? 76? No, it's a little less. Oh, there's 20.8. Rhenium. 20 times more dense than water. That's pretty dense. That's cool. All right. So guys, you okay on this question? One more to do and we're done. And guys, it rolls like this. You'll notice in this question, we were given the mass and we were given the volume and we solved for density. But guys, it doesn't always happen that way. I would encourage you to write this one down with me. Guys, the question says this: what is the mass of 1,250 milliliters of aluminum? So guys, this is the question. This is 1,000, this is 200, and this is 50. So guys, the question is if this was made of aluminum, solid aluminum rather than hollow plastic, what would it weigh? If it was made of water, it would weigh 1,250 grams. But guys, is it going to weigh more or less than that? Does aluminum float or sink in water? Aluminum sinks. So we know that whatever this weighs, it's going to be more than 1,250 because that's what water would weigh. This will weigh more than that because we know that aluminum doesn't float. So guys, let's figure it out. What does this much aluminum weigh? So again, guys, we need an equation. Now, gang, in this equation, what are we solving for? Density, mass, or volume? Mass. So if it's helpful for you to do one of these so that you know, guys, we are solving for mass. So if we're solving for mass, we need to know the density. And they didn't give it to us. It's on the periodic table. Guys, how many significant digits does it give you on there? Does it just say 2.7? Okay, because mine, actually, it's interesting. This guy right here, again, it's a little older version, gives you 5. This one says 2.6989, but yours says 2.7, so let's use that. So guys, the density then is 2.7 grams per milliliter. Don't forget units. Then guys, we want to know the mass, so we're going to call that X. And then we know the volume, that's 1,250 milliliters. Now guys, here's where the magic happens. Milliliters cancels top to bottom, and we're left with grams. But that's what we should be left with because we're solving for mass. So now guys, we need to do the math, and we get 2.7. And algebraically, we solve this by cross-multiplying. So 2.7 times 1250. And guys, I get 3,375 and a bunch of zeros. But now we need to think about significant digits. In 2.7, we've got 2. What about in 1250? 3. So that means we get 2 significant digits in our answer. And that rounded to 2 significant digits would be 3,400 grams. So guys, that much aluminum would weigh 3,400 grams. How are we doing? You guys okay? Okay. So guys, here's what we've got. This homework assignment is actually only 4 questions. Guys, in the same way that we write out equations when we solve things on the board and in lab, guys, be writing down the equations here. So you've got 4 homework questions to do, and you've got a lab that you could dial in and perfect while it's fresh in your mind. How you choose to prioritize this work is up to you, but understand, guys, they're both due on Thursday. If you get your lab done today, you are more than welcome to turn it in. If you get the homework done today, hang on to it because we'll grade it first thing in. We will grade the homework, and then we will get you quickly over to lab so that you can gather up your density data so that you can then work on writing up that lab. So guys, questions about what we're up to? Y'all okay? Okay, so guys, let me stop recording. You dig in. Let me know if I can help in any way. And you've got about, oh nice, like 27 minutes to get stuff done. That's a good thing. Go get them.